Dear cosmic curious souls and explorers of the unknown, prepare for a breathtaking journey that transcends the confines of our own solar system. Imagine the thrill of encountering something that doesn't belong in our cosmic neighborhood, a silent messenger from other stars, a piece of a stellar puzzle forged in furnaces beyond our immediate comprehension. We're talking about interstellar comets, and the latest to visit us, known as 3I/Atlas, isn't just a spectacle to behold, it's a rare key to unlocking cosmic mysteries of epic proportions, a window into the conditions of a planetary system completely alien to our own, carrying secrets of distant star formation and a history that may predate our own. This singular object offers us an unparalleled opportunity to test the boundaries of our knowledge and re-evaluate our understanding of the universe. The narrative of this incredible cosmic saga began to unfold on October 19, 2017, when, for the first time, ground-based and space-based instruments captured the trail of an object from beyond the gravitational bounds of our Sun named 1I/Oumuamua. It represented a revolution in our observations. Over countless eons, many such visitors had certainly traversed the vast expanse of interstellar space and entered our system, but it was only with Oumuamua that we had unequivocal certainty. We had detected an object originating beyond the orbit of the last planet, originating from a mysterious region around another star, somewhere remote in our vast galaxy. The initial excitement surrounding the discovery of this first interstellar traveler was palpable, sparking intense discussions about its nature and the secrets it might hold, opening a new chapter in cosmic exploration and demonstrating that the universe is full of surprises for those who dare to look. Naturally, human imagination soared beyond the confines of established science, and the most fantastic theories about 1I/Oumuamua quickly emerged. Some considered the remote possibility that it was not a natural formation, but rather an artificial creation, perhaps an advanced spacecraft from an extraterrestrial civilization. And let's face it, it would have been infinitely more fascinating if it had been such a contact, assuming, of course, that their intentions were benevolent. However, meticulous analyses, orbital calculations, and direct observations revealed its true identity: an object, yes, unusual in shape, but still a typical star in its constitution, exhibiting the characteristics of an asteroid, yet unmistakably shaped in a stellar nursery light-years away from our solar home. Its composition and behavior dispelled the most exotic speculations, anchoring its identity in the realm of pure astronomy, albeit exotic and revolutionary. Less than 2 years after the impact of the first detection, on August 29, 2019, the heavens gifted humanity with yet another example of this extremely rare class of objects, the second interstellar visitor, affectionately named 2I/Borisov. This time, the newcomer exhibited characteristics more in line with our classical understanding of a comet. As it ventured closer to our Sun, the star's intense heat caused its ancient ices to sublimate, transforming them directly into gas, which dragged with it immense amounts of cosmic dust, in the process carving a dazzling tail that streaked the night sky. This cosmic spectacle reaffirmed the reality of visitors from beyond the stars, showing us that our cosmic neighborhood is not as isolated as we once thought, and that the universe, in its infinite generosity, would continue to surprise us with new emissaries from distant systems, enriching our gallery of observable celestial objects. The saga of interstellar visitors continued, and on July 1, 2020, we were blessed with the detection of the third specimen in our system, the intriguing 3I/Atlas. As on previous occasions, the news sparked the collective imagination, and once again, speculation about the possibility of it being an artificial object resurfaced with renewed vigor. However, detailed and exhaustive observations conducted by the most advanced telescopes of our time, including the unparalleled capabilities of the Hubble Space Telescope, HST, and the penetrating vision of the James Webb Space Telescope, JWST, revealed a scientifically exciting truth, though perhaps less fantastical to some. 3I/Atlas exhibited the same characteristics we identified in 2I/Borisov, behaving like a typical comet, expelling gas and dust as it approached the Sun, solidifying its identity as yet another icy ambassador from the stellar depths, disproving UFO theories but also proving the beauty and diversity of the comets that visit our system. The true wonder, the reason behind such enthusiasm in the scientific community, lies not in their ability to frighten or deceive us, but in the rare and invaluable opportunity these comets offer. This is not an alien spacecraft, but rather a time capsule forged in the furnaces of another planetary system. These objects allow us to closely study something that did not form under the gravitational and material influence of our own Sunday. It is a unique opportunity to examine the fundamental similarities and differences between the comets and asteroids that orbit our Sun and those that come from distant star systems. This comparative analysis allows us not only to better understand the formation of planets and stars in other regions of the galaxy, but also to test the universality of the laws of physics by observing how the same fundamental principles operate in different cosmic contexts, offering a glimpse into the different recipes for creating worlds throughout the universe. It is widely accepted in science that the fundamental laws of physics operate consistently throughout the universe, a universal truth, so to speak, whether here on our humble blue sphere, on the farthest outskirts of our galaxy, or even in another galaxy entirely. However, the universality of the laws does not imply that cosmic outcomes and configurations are identical everywhere. Quite the opposite. Just as an orange can vary in color, flavor, and texture depending on its growing conditions, a planet or comet can manifest distinct characteristics depending on the elements and energies present in its stellar nebula of origin, even under the same laws of formation. This teaches us that while the basic principles governing gravity and nuclear fusion are constant, the abundance of certain elements or the intensity of stellar radiation can lead to worlds and celestial objects very different from those we know so well in our own cosmic backyard. To illustrate this intriguing complexity, consider oranges. We all know that they grow on orange trees and that, upon ripening, their peels typically take on a vibrant orange hue. However, if we plant an orange tree in different types of soil, it will still grow, perhaps with variations in vigor or productivity. But the truly curious part arises when we consider that in certain climates, such as tropical ones, an orange, even fully ripe, can remain green-skinned, deceiving those unfamiliar with it at first glance. The laws governing tree growth and fruit pigmentation are immutable, functioning equally well whether in an orchard on Earth or in an experimental greenhouse on Mars. We would never expect, however, that an orange pit would turn into popcorn or emit a song on FM radio. This analogy helps us understand that interstellar visitors like 3I/Atlas, though governed by the same laws that shaped our solar system, can exhibit green shells, unusual characteristics reflecting the different ground conditions from which they came. Comet 3I/Atlas is more than a mere space traveler, it is a fragment of frozen time, a relic, potentially far older than any rocky or icy formation within our own solar system. More than a fossil from our own cosmic neighborhood, Atlas is a veritable fossil forged in the furnaces of distant time and space, an untouched piece of star formation from another system, bearing the marks of unimaginable events and celestial landscapes never before seen by human eyes. While we marvel at the starlight that reaches us like an echo from a distant past, or observe the images of probes that have landed on the Moon and Mars, having a concrete piece, a physical bit of something that formed who knows where in our galactic vastness is a truly unprecedented rarity. It is a chance to touch, so to speak, a living history of the cosmos, a tangible bridge to other spheres of stellar existence, which makes it one of the most valuable and intriguing objects we could study, instigating boundless curiosity about its origins and secrets. As with all cosmic rarities, it is imperative that we make the most of this unique opportunity to observe and study 3I/Atlas. This opportunity is fleeting. Not only will Atlas not return for a second encounter with us, but it is also uncertain when another similar object will cross our path again. Its journey through our system is a temporary window into the unknown, and soon it will vanish into the interstellar abyss, taking with it the secrets we have yet to fully decipher. The good news is that Atlas will remain within reach of our most powerful telescopes, allowing continued observations and studies until early 2026. After that date, it will continue its inexorable journey back into the cold depths of interstellar space, and then we'll have to hope that another errant messenger from a distant star system will grace us with a visit in the years to come, reaffirming that the universe remains an inexhaustible source of mysteries and wonders, waiting only for us to reveal them with time in our eyes.